All right, the top sections are asking us to use the quadratic formula to solve. Oops. And so x equals negative b plus or minus square root b squared minus 4ac all over 2a. Let's get that formula written up there for reference. So we need a, b, and c on each one. And then we're going to go ahead and plug in. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Negative negative 12 becomes positive 12 over 2. I'm splitting this up. 144 minus 32. Okay, this is going to become 6 plus or minus, and then 144 minus 32. Grabbing my calculator. That's 112. And now this 112 gets split up. I think 4 can go in. Yes. Okay, let's try 16 dividing in. It does go in. So if 112 is 16 times 7, or 4 times 4 times 7, a 4 can come out and a 7 stays in. So 4 root 7 over 2. That means that our final answer is going to be x equals 6 plus or minus 2 root 7, because 4 divided by 2 gives us 2. This part right here is simplified in the final step. So here's our final answer. 2 real roots, 6 plus 2 root 7 and 6 minus 2 root 7 are our 2 roots. We're just solving, so we're leaving it there. We were not asked for the intercepts on this one. Okay, pause the video, go try the next one, getting A, B, C, and you try to plug in and see how far you can get. So 12 times 6, and negative times negative is positive. 12 times 6, 72. So root 76, let's see if 4 goes in. It does. So if 76 breaks down into 4 times 19 or 2 times 2 times 19, then we're going to be able to take a 2 out and leave the 19 in. So final answer, negative 1/3 plus or minus 2 root 19 over 6. And then we notice that the 2 and the 6 can actually reduce, just like the front did, into 1/3. So actually, I wouldn't, when these are fractions, let's not split it apart. I'm going to show you the other format of how the answer can look that I think looks better on one like this. And then final answer becomes negative 1 plus or minus root 19 over 3. 2 real roots, because your discriminant is 19, or originally it was 76. Okay, get ABC on the next one. Go try it. Negative negative 3 becomes positive 3. Square root of 9 Okay, what was that at the back? Negative 14. So negative 4 times negative 14 is 56. And 56 plus 9 is 65. And since 65 breaks down into 5 times 13, two prime numbers, that cannot reduce anymore, and it is done. 2 real roots. All right, get ABC on the next one. Pause the video, see how far you can get. $20 times 2, so that's going to be negative times negative is that, so 40. Is that 76 again? Let me just double check that. Minus 4 times 5 times negative 2. 4 times 5 is 20. 20 times 2 is 40. 36 plus 40. So we just broke down the 76 in the problem before. Over here, 76 was 2 root 19. And then 2 goes into 2, 2 goes into 10, 2 goes into 6. So final answer, negative 3 plus or minus root 19 over 5. 2 real roots. Oops. So 64 minus 40. Okay, this turns into root 24. And root 24 breaks down into 2 times 2 times 6. So a 2 comes out, a 6 stays in. But we notice that these 2's can also cross out. And so final answer, 4 plus or minus root 6. 2 real roots. Last but not least, four times 7, negative 7. Okay, this isn't going to work out. Hang on, I got to stretch it over. Minus 4 times negative 7. Sorry about that weird dot. And then all over 2 times 4. So negative 8 becomes positive 8. 64 minus, and then a negative, so that's going to become positive 16 times 7. So that's 112 all over 8. So 112 plus 64, that's 176. And so I break down the 176, and it's 11 times 16, which is 11 times 4 times 4. So 4 comes out and 11 stays in. So my final answer here, because 4 and 8 can reduce, is 1 plus or minus root 11 over 2. That 4/8 becomes 1/2. And those are my 2 real roots. So at this point, after practicing those 6, you should be feeling pretty solid on the quadratic formula. Let's do one of each of the other. What times what equals a product of negative 88 and a sum of 3? I hope you thought of 8 and 11. It needs to be 11 minus 8 so that we get that product of positive 3. X minus 8, x plus 11 are our factors. It then tells us to solve them by zero product property. And so that gives us a solution of positive 8 and a solution of negative 11. It then asked us to write the x-intercepts. So we write negative 11, comma 0 and 8, comma 0. It means it wanted the whole shebang all the way to x-intercepts. The last one, we're going to complete the square to get to vertex form, and then we're going to keep going. So step 1, make space. Actually, I'm going to not put 0 equals yet because it first just asks for vertex form. So g of x equals, step 1, make space. Step 2, b work. Divide that b in half and square it. I'm getting that we are going to add 4 and subtract 4. This makes the x minus 2 squared perfect square factors. And then minus 20 comes from the negative 16 minus 4. This, when it asked for vertex form, right here, this is the answer for vertex form. But then the whole problem said use the indicated method to solve. So we keep going on this one now by setting it equal to 0. And we're going to add the constant to both sides so that we can square root. Root 20 breaks down into root 4 times 5, or 2 times 2 times 5. So a 2 comes out, a 5 stays in. And then we add 2 to get 2 plus or minus 2 root 5 as our solutions. And then for the x-intercepts, 2 plus 2 root 5, comma 0, 2 minus 2 root 5, comma 0. Woo, done. There's your full x-intercept answers right here and right here. It means we have 2 real roots for both of these factored and completed the square quadratics. Great job.